Welcome to lecture 5.3. We're going to discuss proportions. So let's consider these two figures, and they're pretty much the same figure except the sizes are slightly different. One is a 7 by 7, the other is a 6 by 6. We can say that the figures are proportional to each other. But what exactly is proportion? Well, the definition of a proportion is a statement that ratios are equal. If A over B and C over D are equal ratios, then the statement A over B equals C over D, where B and D are not zeros, because we don't want zeros in our denominator, is called a proportion. And we can also say that each number in the proportion is called a term, and we specifically give numbers to each term. So A would be the first term, B would be the second term, C would be the third term, and D, would be the fourth term. And one more thing that we need to know about terms, the first and the fourth terms. So A and D are called the extremes. The second and the third terms are called the means. So B and C are called the means, A and D are called the extremes. So let's take the proportions 3/4 and 6/8. And we're going to name, just for practice, each of the four terms, which ones are the extremes and which one are the means. So the first term would be 3. The second term is 4. The third term is 6. The fourth term is 8. The extremes and the extremes, 3 and 8. Remember, it's kind of in that A slot and the D slot. So the extremes are 3 and 8, and the means are in the BC slot, which is the 4 and the 6. And the fundamental property of proportions, it means that the product of the extremes is equal to the products of the means. And remember, the extremes are A and D, the means B and C. So if we take the product of the extremes, A times D, that will equal B times C, the product of the means. Now remember, B and D are not 0 because they're in the denominator, so it's just not 0 equals 0. It is actually going to be a number equals a number. We can use our fundamental property of proportions for verification that proportions are true equal proportions, but we can also, and we'll get to that next, is where we can solve if we're missing some information. So if we have a variable, an unknown, we can actually use this fundamental property of proportions to solve for that variable, along with some other properties that we've learned previously. So let's just verify that 3/4 does equal 6/8. So if we do that, 3/4 equals 6/8, we're going to take the extremes, 3 times 8, the means, 4 times 6, 3 times 8 is 24, 4 times 6 is 24. Indeed, they equal one another. Likewise, if we have another fraction, another ratio, 17/34, as well as 1:2, do those equal each other? Well, again, we're going to take the extreme, 17 times 2, and the means, 34 times 1. Well, 17 times 2 is 34, and of course 34 times 1 is 34. So 34 equals 34. So using the fundamental property of proportions, I have an unknown here. And I can use that property to be able to solve for x. So I'm going to take my extremes and multiply them, take my means, multiply them, and then I'm actually going to use my multiplication property of equality to actually solve for x. So here are my extremes, 2 times x, my means, 3 times times x is just 2x. 3 times 4 is 12, but using my property of multiplication of equality, I can multiply by its reciprocal for each side, so it's 2, or think of it as division. 2 divided by 2 will give me a nice 1. 12 divided by 2 is 6. So if we wanted to see if indeed this holds true, off to the side, 2 over 3 equals 4 over 6. Again, I'm going to use my fundamental property of proportions. 2 times 6, does that equal 3 times 4? 2 times 6 is 12. 3 times 4 is 12. Yes, indeed, it holds true. So let's work through a problem completely together. So I'm going to again take the extremes times the means. So 5 times 13, does that equal? It equals y times 10. 5 times 13 is going to be 65. Y times 10 is 10y. Now I'm going to use my multiplication property of equality. So I can divide each side by 10. And now I can have 6.5 equals y. But let me just plug that 6.5 in and double check to see if indeed it works out. So again, I have 5 times 13, 10 times 6.5. Well, 5 times 13 is 65, and 10 times 6.5 is 65. So the check does work, and we did get the correct solution. So a little bit more difficult this time because we do have a decimal, not just whole numbers, but we have a decimal to contend with. But it's still the same process. Doesn't matter what the numbers are, the process is the same. So I'm going to take my extremes, n times 8, should equal 3 times 0.4. Well, n times 8 is just another way of saying 8n. 3 times 0.4 is 1.2. Why? Because 4 times 3 is 12, but I have one decimal point, so I do need to move the decimal point over 1 to the left, so it's 1.2. Now, need to use my multiplication property of equality. Divide by 8. Divide by 8. So n will equal, off the top of my head, I'm not sure, so I'm going to come over here and do the math over here. That should look like enough. 8 doesn't go into 1, but it does go into 12 one time. Bring down the 0. 40. Alright, so n equals, 1, 5, 0.15. Let's work through one more example. Now, I don't want you to get scared off because there is a fraction here. Let's treat it just like any other number, and we're going to use our fundamental property of proportions to solve for x. So let's take the extremes. 2/3 times 6 should equal 5 times x. Well, 2/3 times 6, I can treat the 6 like a fraction by putting a 1 on the bottom of it, right? No harm, no foul there. I can either reduce or just do the multiplication and then reduce later. So I think I'm just going to do the multiplication. 2 times 6 is 12. 3 times 1 is 3. That equals 5x. Well, 3 goes into 12 4 times, so I can reduce that. 5x. Now, 4 equals 5x. But again, I don't want to know what 5x's are. I want to know what 1x is. So therefore, 4 over 5 equals x. And you could plug that back in, do your, we also call this cross multiplication, do your cross multiplication, and then find out that yes, indeed, the two ratios equal each other. A similar to this, where you think, well, what do? I don't have another number to multiply by. But you do. Remember that all whole numbers, there's an implied 1 as the denominator. So I can rewrite the problem as b over 15 equals 2 over 1. Well, now I can still do the multiplication. It's going to be b times 1 equals 15 times 2. Well, 15 times 2 is 30. B times 1 is just b, so b equals 30. And let's just plug it in to see if it does make sense. Well, when b is 30, I have 30 over 15. Does that equal 2? It sure does, because 15 goes into 32 times, so 2 does equal 2. So that's it for this lecture. So until next time, be seen.